Welcome to the continuation of Master Crammer Calculus Made Easy series. In this video, we'll be having more examples with limits on trigonometric functions. So for our first example, we will have the limit of sine 3x over x as x approaches 0. So we can write this as the limit of sine 3x over x as x approaches 0. Now, if I put a 3 here, number 3, and then I put a 3 here, so 3 over 3 is equal to 1. So if I put a 3 here, but in the denominator, but if I put a 3 as well on the numerator, this just basically multiplied by 1. You're not changing the original expression of sine 3x over x because 3 over 3 is equal to 1. Now, let 3x be equal to y. Now, as x approaches 0, we can say that 3x approaches 0. Okay? Now, as x approaches 0, you multiply this by 3x, you multiply this by 3x, you have 3x approaches 0. Now, since 3x is equal to y, we can see here 3x is equal to y. We can say as well that y approaches 0. If x approaches 0, 3x approaches 0, then y approaches 0. Now, therefore, we can rewrite now our expression substituting y with 3x. We could write it as the limit, okay, of sine, since 3x equal to y, y over 3x again is equal to y over y. Now, instead of writing x approaches 0, we will write now y approaches 0. Since as x approaches 0, y approaches 0. Y approaches 0. Multiplied by 3. Now, we can put this 3 behind it, so we can actually write this as the limit of sine y over y as y approaches 0. We can put 3 here. Now, recall that the limit of sine y over y is equal to 1 as y approaches 0. So therefore, this is now equal to 3 multiplied by the limit of sine y over y as y approaches 0 is equal to 1. Hence, 3 times 1, you'll get 3, and 3 is our final answer for this problem. Okay, for our next limit expression, it's the limit of 3 multiplied by the secant of y minus 1 over y as y approaches 0. So, immediately you can see here 3. You can put 3 here behind the limit. We can put it outside because if you recall, the limit of a constant multiplied by a function is equal to the constant multiplied by the limit of that function. So I'll just put 3 outside to be like this. 3 limit, okay? And secant of y, if you recall, secant of y is actually equal to 1 over cosine of y, if you recall from our basic trigonometry. So secant of y is equal to 1 over cosine of y minus 1 all over y as y approaches 0. Now, let's multiply now. Let me rewrite it again. 3 limit of 1 over cosine of y minus 1 over y as y approaches 0. Let's multiply the numerator and denominator by cosine of y. So again, this is not a problem because cosine of y over cosine of y is equal to 1. So it does not really affect, it doesn't affect at all our expression. Let me just delete this to have some space. Now, if I multiply cosine of y with cosine of y, you'll get 1. Cosine of y times negative 1 will be negative cosine y. So let me write it here. So if we simplify this, 3 limit, again, cosine of y multiplied by 1 over cosine of y, you'll get 1. Cosine of y times negative 1, you'll get negative of cosine of y all over cosine of y times y will be y multiplied by cosine of y as y approaches 0. Now, we can rewrite this as 3, the limit of 1 minus cosine of y over y multiplied by 1 over cosine of y as y approaches 0. Now, I can take now the limit of this and the limit of this. Recall, the limit of two functions is equal to the product of the limit of each function, if you recall from our limit laws video. So let me clean this up a bit, have some space. Now we can express this one as 3 multiplied by the limit of 1 minus cosine of y over y as y approaches 0 multiplied by the limit of 1 over cosine of y as y approaches 0. If you recall, as I mentioned a while ago, the limit of the product of two functions, in this case, one function is 1 minus cosine of y over y, the other function is 1 over cosine of y, can also be expressed as the limit or the product of the limit of each of the function. In this case, limit of 1 minus cosine of y over y as y approaches 0 multiplied by the limit of 1 over cosine of y as y approaches 0. Now you can simplify this further into, I have here 3. If you recall, 1 minus cosine of y over y as y approaches 0, this will be 0. And 1 over cosine of y as y approaches 0. Cosine of 0 will be equal to 1, 1 over 1. Simplify this further, 3 times 0 is 0, times 1, 0. So our final answer, therefore, here is 0. Now let's now have another example here. The limit of sine 7x over 4x as x approaches 0 is equal to a certain value, which we're going to find out. So let's express this into the limit of sine 7x over x multiplied by 1 over 4 as x approaches 0. So you can see here, it's basically the same. There is no difference here. Sine 7x over sine 7x over 4x is the same as this one. Sine 7x over x multiplied by 1/4. 4 times x is basically 4x. So there's no difference between these two. Now, if I put a 7 here, okay, and then if I put a 7 in the denominator and put a 7 there, then that's fine, because 7 over 7 is equal to 1. Again, I'm not changing the expression, still the same. There is no effect. But now, I can express this in a different way now. Take note. If, or let 7x be equal to y. Now, as x approaches 0, of course, y approaches 0. So therefore, I can now express this in a different way. The limit, assuming that 7x equal to y, of sine y, because 7x equal to y, over 7x equal to y again, over y, as y approaches 0, multiplied by 7 over 4. 7 over 4. Now I can put this behind the limit, so I can rewrite this as 7 over 4, the limit of sine y over y as y approaches 0. So recall that the limit of sine y over y as y approaches 0 is equal to 1. So therefore, this is 7 over 4 multiplied by 1, and the final answer is 7 over 4. Now, just to show you one technique, look at this. Limit of sine of 7x over 4x as x approaches 0. What you do is, you just look at this one. Okay, you have 7, limit of sine 7x over 4x. You have 7 here and 4 there. And what's the final answer? 7 over 4. So even if I change the numbers here, let's say limit of sine 8x over 3x, the answer will be 8 over 3. If instead of 7 over 4, you have like 10 over 3, so the answer is 10 over 3. If this is 2, instead of 7, this is 2. Instead of 4, this is 5. So the answer will be 2 over 5. So you can just look at the numbers here in the numerator as well as in the denominator. Those two numbers, the quotient of that is the final answer. So in this case, sine of 7x over 4x, you look at 7 and 4. The final answer, therefore, is 7 over 4. So if it's just a multiple choice, you can use this technique. But if the exam requires you a solution, then you can use this solution. But to check it, it's very easy. Just look at the number in the numerator and denominator. Well, time is up. More examples in the next video.